So we're going to talk about the domains of rational numbers. So rational numbers are a fraction. It's a number that can be written as the quotient of two integers as long as the denominator doesn't equal 0. For a rational expression, that can be written as the quotient of two polynomials as long as the denominator doesn't equal 0. So here's some examples of what rational expressions might look like. So we're going to actually be looking at rational functions. And this would what a rational function would be. The only difference between these is now we've got f of x is equal to that. So that's what it's looking like. And we're going to be looking at finding the domains. That's all we're going to look at this point in time. So to find the domain of a rational expression, we're going to set that denominator equal to 0, and we're going to solve. That number can't be in the domain of the function is what we're looking at. So if we end up with x minus 3, if it's in our denominator equal to 0, we'll solve this and get x equals 3. So that means that x can't be 3. So the domain would be that x could be anything except x can't be 3. All right, so let's go look at some examples. So we're looking at finding the domain. So for example 1, we have f of x is equal to 8x cubed plus 7x squared plus 20 all over 2. So to find the domain, all we care about is setting that denominator equal to 0. Well, 2 can never be a 0. There is no variable here. And because it can never be a 0, then we're looking at our domain is going to be all real numbers or from negative infinity to infinity. So it would be all real numbers because we can't get anywhere else with that. 2 can't ever equal to 0 because there's no variable. It can if we were subtracting 2, but we're not. We're just looking at this equal to 0. All right, so let's look at example 2. If we have g of x is equal to 5x squared minus 3 over x minus 1, we'll take our denominator, x minus 1, set it equal to 0. Add the 1 to both sides, and we get x equal to 1. What that really means is that x can't be equal to 1 because 1 will cause us to get 0. 1 minus 1 is 0. So our domain would be, depending on what they're looking for in your answer, it could be that it is x is a real number and x can't be equal to 1. If they're looking for interval notation, then the easiest way for you to do that is draw a number line, put the 1 there because it can't be equal to 1. You don't need a bunch of other numbers. We're going to look at it. It's going to be this side and that side, every number but 1. So it'll be negative infinity to 1 union with 1 to infinity. So that would be the interval notation of our domain. All right, let's look at example 3. So if we have h of x is equal to 7x minus 2 over x squared minus 2x minus 15. Now notice we never look at the tops of the fractions because those don't have anything to do with it. It's only about you can't divide by 0. So that's the numbers that cannot work in the domain. So we are looking at taking our x squared minus 2x minus 15, setting it equal to 0. And then we need to factor it. You can factor it any way that you want to. You can use the AC method. In this case, you could use the quadratic formula because it's set equal to 0, so you could solve it that way. There's many options that you have. I'm just going to factor this. I'm not going to show all the steps of factoring because we've already covered that. But we have x plus 3 times x minus 5. That would be how that factors. So we'll have x plus 3 equal to 0, x minus 5 equal to 0. Subtracting the 3 from both sides, we get x is equal to negative 3. Adding 5, we get x is equal to 5. So what that means is x cannot be equal to negative 3 and x cannot be equal to 5. So if you're looking at x is a real number x cannot equal -3, x cannot equal 5. If we're looking at interval notation, again, drawing a number line is usually the easiest way to do it. And now it'll be everything but those two numbers. So it'll be -infinity to -3 union with -3 to 5 union with 5 to infinity. And they all have parentheses because you can't equal any of those because that'll cause us to divide by 0. And that's how you're going to find your domain of your rational functions.